I'm going to take you through a few more of these examples, so I'll move as quickly as I can. We're going to go ahead and find the x-intercept. Remember, that's where y equals 0. When we cross multiply and solve that, we end up getting x is 0. So that means the point is 0, 0. I'm not going to go ahead and find the y-intercept because I know the y-intercept is also going to be 0, 0. So we just have one intercept and it would be 0, 0. The next thing I'm going to look at are my asymptotes. So we have vertical asymptotes when the bottom is equal to 0. So I'll be looking at this bottom part and setting it equal to 0. So that would be when x is plus or minus 3. So I have two vertical asymptotes, one at x equals 3 and one at x equals negative 3. The horizontal asymptotes are where the limit as x approaches infinity. So I keep the highest degree on top and the highest degree on the bottom. Notice it is a negative x squared. When I cancel or simplify this, I end up getting 2 over negative x. So as this number gets really, really large, 2 divided by a really, really large number goes to 0. So my answer would be y equals 0 for my horizontal asymptote. Now I really should check the limit as x approaches, and I need to go back here and adjust these on the last one as well. I should have actually been finding the limit as x approaches plus or minus. So the limit as x approaches positive infinity and as x approaches negative infinity. That doesn't do anything to these problems. The only time that this is going to happen is if we have a square root problem, which I will show one of those to you here in a little while. So I'll quickly sketch the graph. I have a vertical asymptote at 3 and another one at negative 3. I have a horizontal asymptote at y equals 0. I know that I have an intercept of 0, 0. If I would check all the other parts of this, I would be able to come up with more of the sketch, but we're not going to do that in this problem. We'll just use our graphing calculators and sketch this graph, and then we'll talk about the symmetry. This is actually symmetric about the origin, and how I know that is that the point 1, 1, I guess that isn't necessarily 1, 1. Let's see, the point, let's see, this would be 2 on top if I was to put 1 in for x, and I'd have 8 on the bottom. So I would actually have 1/4. So the point 1, 1/4 is on the graph, and so is negative 1, negative 1/4. And we can see that if I put negative 1 in here, I'd end up with a negative 2 over, that would be 9 minus negative 1 squared, which would be 1. So you'd end up with negative 2 over 8. So because the x comma y and the negative x comma negative y, both of those are ordered pairs of the graph, this is symmetric about the origin. Symmetric about origin. That's probably one of the hardest symmetries to find, but typically if it goes through 0, 0, it will be symmetric about the origin or symmetric about something. I have 2 more of these examples, but I'll have to do one more video for those.